hope you are doing extremely well. This is our Blind 75 series and we have successfully completed first problem from here, climbing stairs. Let's move on to the next problem, coin change. Pretty interesting problem, medium level, and we'll start with the problem statement. We'll see the top down approach and bottom up approach of dynamic programming here. Stay with me with the whole video and definitely it will become very simple for you. So if we take the first example, we will get a array coins which will be containing some denominations, and another thing, amount that we have to make using the coins of the given denomination. And one thing we need to keep in mind is that we have infinite supply of each kind of coin. All right, when first I tried this problem, I thought of doing like this. This is our coins array, this is our amount. I thought that if I start with the maximum denomination and eventually move towards the smaller denominations and keep on selecting the number of coins I will have at the end, I will have minimum number of coins for that particular amount. But it is not actually true. Let me show you. Here if we start from 5, we can take 2 coins here maximum, and it will give us value as 10, and we need one more. There's one more rupees that will take from 1 coin. We'll take its amount as 1 and we'll get its value as 1. Overall we'll get 11 amount and we end up consuming 3 coins. Here in this coins the answer is 3. We cannot have any other combination in which we can use less than 2 coins and get amount as 11. But if you consider this other example 1 3 7 8 at the coins array and amount as 10, using the above technique, if I start with the maximum denomination first, then how many coins I can take from 8? I can take maximum 1 coin only, because 2 will make value 16. We have to only make the value as 10, so it will give me value as 8. Then after that I need 2 more rupees that I will take from this 1 rupee coin. I will take its 2 unit and I will get value as 2. Finally the amount as 2 and number of coin as 3. But is the 3 correct answer here? No, it is not, because we can simply take 1 coin from 3 and 1 coin from 7 and simply we will get amount as 10. We need only 2 coins. So this technique is not going to work always, and you must have understood. We'll not use this technique, we'll use here dynamic programming. First we'll start with top down approach. It is recursive approach. Here we solve a part of problem and pass rest to recursion. And one more thing, we are going to use DP here because there will be overlapping subproblems here. If we take the above example where the amount is 11 and we can make these 3 choices 1 to 5. If I am taking a 1 rupee coin, I will left with amount as 10. In this case I will left with amount as 9. In this case 6. Now again I will left with 9. Now you can clearly notice that there are overlapping subproblems present here. So we need to use DB array for storing the answer for overlapping subproblems and then later using it in later subproblems. Alright, now we'll we'll simply jump onto the code and I'm going to explain here only. As we have discussed, first I will create a dp array like this, and it should have size as amount plus 1 and value of each index will be minus 1. Why I have taken amount plus 1? Because here this dp array is storing, oh, these are the indexes 0 1 2 3 4 5. It is simply storing for 0 amount how many coins we need. Obviously if there is no amount we would not need any coin. And similarly, if the amount is 5, then we need this index in our dp for getting the final answer. And for getting this index, the size should be plus 1 because we have added this 0 index plus 1. So I need amount as index, so for size I will add 1 here, so I have added 1. Now let's return the outcome of helper function. Let me do it another way, because if we don't have any valid answer we have to return minus 1. First let's create our helper function, then we will return its value. It is going to be our recursive function helper, then vector int coins, then int amount, then vector int dp, that too with reference. Alright, now we'll start this recursive function with the base case, and base case will be when the amount is 0. Base case is the point where we need to stop the recursion. So when our amount reaches 0, we will stop there and we will simply return number of coins as 0. Here later on I will make sure that we are not making any calls for negative amount. So I am not handling it the case when the amount becomes negative, because it is not going to become negative. Now I am checking my dp array if answer is already present there. If dp amount is not equals to minus 1, it means that the same sub problem I have seen before and I have stored it in my dp, so I will return the same answer here. Now I'm creating this for loop for iterating over the coins array, and here let me take a variable int number of coins, that will be our final number of coins. Let's start it with int max because I have to minimize it, so I am starting with the maximum possible value here. Now I am going to make a recursive call. I am applying here conditions so that I am not ending up with making a call for recursion with negative amount. So I am checking here if amount is greater than or equals to current value of coin. Why I am doing this? Because I will take a coin and I will pass rest of the amount for recursion to process it, and I have to reduce the amount also. I will reduce the amount by amount minus I. I will reduce the amount like this, amount minus I, and this will remain positive till this I is smaller than or equals to amount. Till then this whole value will remain positive. So I have done the same thing till this till the point when I is smaller than or equals to amount. I am safe to make the recursive call. So I am making here the recursive call and storing its answer in this variable as result, and helper I will pass coins array, then amount minus I, and at last our dp. And with this help of the result I am going to update my number of coins. It will be, if the result is int max. Means I was not able to go inside this if my number of coins will remain int max, which I will return here. So I will get result as int max. If it is so, means number of coins will not change. If it is not, if the result is not int max, then it will be some value. So what has been returned by the recursion, I will add one from my side because I have added one coin from myself, so I have added that, and I have to minimize. So I will use min function and use number of coins previously present. So I will be making calls for each coin and eventually minimizing the number of coins. So I am again and again comparing with number of coins only, because if with a coin it can be larger, with another coin this value number of coins can be smaller. So at the end, when I am coming out of this for loop, I will end up with minimum number of coins in my number of coins, which I will return after passing into my DP like this. Number of coins, and now I can call this function helper. I'll pass coins, I'll pass amount, then DP, and it can return me int max. But if a valid answer is not possible, then I have to return -1. So I will check. I will store it also in res. I will check if res is int max or not. Return res is equals to if it is so, then I will return -1. Otherwise I will return result like this. This is it, whole code, and let's try to run it. There is some problem, number of coins, some typo here. I have corrected it. Now let's try again. Yes, it is working fine. Let's try to submit it. Yes, it got accepted. It is working absolutely fine. So this was the top-down approach in which we have used recursion. Now let us see another approach, which is bottom-up approach. What is this bottom-up approach? It is actually iterative. We'll start with the smallest subproblem. With the help of and we'll decide its answer with the help of this. We'll calculate other subproblems, then eventually we'll get our final answer from the solution of other subproblems. Final problem answer. It is going to be the iterative approach. Now let's directly jump onto the code. Again, we need to create DP, because first we'll start with the amount. Here we are creating DP vector for storing the number of coins for each amount. Suppose we have amount given as 5, so we'll create DP like this: 0, 1, 2, 3, 4, 5. We'll start here with this 0, and eventually we'll be filling this, and we'll be returning the final index value. So vector int DP amount +1, and here I am taking value as amount +1. Maximum value we can take this also, because if we have only denomination of 1 rupee coin, then also the number of coins will be amount equals to amount. The answer is never going to be amount plus 1. Alright, now we'll define dp0 is equal to 0. It means then that for amount 0 we need 0 number of coins. Now I am going to fill this dp array from 1. It will be equals to amount I plus plus, and here I will be iterating through each coin. What I will be doing here is that, so number of coins for particular index will be equals to minimum of dpi or dpi minus, I have taken I in above loop also, so I will take j here, plus 1. I'll explain you this in a moment, and in the end I will do the same thing. If dp amount is equals to amount plus 1, it means that we don't have valid answer, we will return minus 1, because initially we have put here amount plus 1 and the end we also got amount plus 1, means we don't have valid answer, we will return minus 1. In other case, with colon we will return dp amount. Like this is the whole code for the iterative approach, that is bottom up approach. Let's try to run it. It is showing me some answer of overflow. Let's check. dpi is equals to min of dpi, then I minus j plus 1. What is the problem? Okay, so I have to put check also here. If j is less than equals to I, then only I can do this, otherwise it will go to the negative index which is not present in our dp. So I have placed here a check till the amount is less than equals to, sorry, it should be greater than. Yes, it was correct. Amount is I, amount should be greater than the value of coin, that is j. Now let's try to run it again. Yes, this time it is working fine. Let's try to submit it. Yes, it got accepted. Now let me try to show you what I have done. The main thing here is this only. Let me take this example 1 to 5 and 11. Yes, when the amount is 11, I will need dp array of size 12, that we know already. It will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let me draw some partitions like this. Alright, then okay, first we have placed here 0, and then we will search for 1 when this I is 1. So deep here from this statement dp1 will be min of dp1 comma I minus j, means I is 1 and j is also 1 here in this case. Value of first coin is 1, so dp is 0 plus 1. dp1 is amount plus 1, that is 12. It is 12. It is 0 plus 1 1. dp1 will remain 1, means we need one coin for amount 1. Similarly, for 2, we'll calculate dp2, and you know what it will be: minimum of dp2 comma dp I minus j, and it will not work for other coins 1 for when the amount is 1, and for coins 2 and 5, because the value of coins is larger than the amount. This condition will not be satisfied. So this we will reach 2 here for the amount, and we'll come again here. So I'm calculating dp2 will be 2, and then 2 minus coins value, again coin will start from 1. 2 minus 1 dp1, we have dp1 plus 1. dp1 is 1, 1 plus 1 is 2. So if we are using coin with value 1, we'll end up using 2 coins for the value 2. So this is when for coin 1 rupee coin, 1 rupee coin. Again we'll run for 2 rupee coin, then it will be minimum of 1 and 2, and it will become dp of 0 plus 1 1. So it will again become 1, like this. So we'll be using we'll keep on using previous values and calculating the next values. We'll end up as 3 here, like this. Let me show you quickly. So we cannot make calls for 5, and for 3 we'll make calls for 1 and 2, and we'll need for 3 we'll need, if we are using 1 coin, we'll need 3 coins. If we are using 2 rupee coin, then we'll need 1 coin. Then for this 4, we'll need 2 coin. For this 5, we'll need 1 coin. For this 6, we'll need 2 coins, one for from 5 and 1 for 1 rupee coin. For the 7, we need 2 coins. For this 8, 5, 2 and 1, 3 coins. For this 9, 5, then 2 coins, mean 3. For 2, 10, and for 11, 2. Let me show you for this 12. dp12 will be min of dp12. Initially it will be amount plus 1, that is 12, amount is 11, 1 plus 1 is 12, and dp11, 1 coin, 1 rupee coin. Okay, it will be 11 will be 2, so it will be 2 in the first step. For 2 rupee coin, dp12 will be minimum of current value is 2, sorry, it will be plus 1 also, so 3, and value is 3. Then dp 12 minus 2 means 10, it is 2. 2 plus 1, 3 also from this case. And for 12, for 5 rupee coin, min of 3, dp of 12 minus 5, 7, 2 plus 1, 3. We'll get 3 at the end. We'll return this as our answer. In this way, this iterative bottom up approach is working. Hope you understood the concept, and we'll meet in the next video. Thank you.